Hello, this is Sal. In today's practice lab, we have the main objective that we need to focus on. There are configurations in this network that were supposed to be pre-configured for you, then to focus on the main objective. But I will do the initial configurations with you, then to work on the main objective so you can have an idea how this lab been prepared for you. The interfaces on the devices has been configured for you already, but for now I will start doing the configurations that we will need to for our lab. I will start with the remote router. But before that, here you can find on the description of this video, you will find two files, one for the packet tracer source file and the documents to walk you through the lab step by step. I hope my videos are helpful for those who are seeking to be Cisco certified. If you like my videos, please subscribe to my channel and share the videos on your Facebook page and give me the thumb up. And please send me if you have any suggestions, questions, or comments. So for now, I will configure NAT on the remote router here. As I said, only the interfaces with IP version 4 and IP version 6 has been configured on this network. Enable, configure terminal, IP NAT inside source list 1 on the interface of serial 000 overload. So now for the interface of gig 00, this is for IP NAT for inside, and the interface of gig 01 also NAT inside, and the interface of serial 00, this is for IP NAT outside. Now I will configure a default route on the remote router, IP route for any network with this subnet mask, and the gateway would be this interface here for the remote route for the next hop on 209.165.200.226. Enter. Next, I will configure DHCP on the router for LAN 1 and LAN 2. IP, now I will configure the excluded addresses for the two LANs, IP DHCP excluded 192.168.1.1 to 192.168.1.9, and the second one 192.168.0.1 to 192.168.0.9 for VLAN for LAN 1 on remote router. Enter. Now for the pool names, here I configure for the LAN on the interface gig 00 as pool 0, G0, and LAN 2 on gig 01 of G1. IP DHCP pool G0. The network of 192.168.0.0 with /24 subnet mask, and the default gateway or default router 192.168.0.1, and the DNS server, it will be this guy here, this DNS server for all the devices on the network, this here. Back to the remote router and the DNS server of 209.165.201.29. Now for the, I'll configure the DHCP for LAN 2. I'll give the pool name of G1. Exit. IP DHCP pool of G1. The network of 192.168.1.0/24 subnet mask, and the default router of 192.168.1.1, and the same DNS server of 209.165.201.29. Now let me check to see if the PCs received their IP addresses. This one did, and the second PC here, and this guy also did. Next, I will configure IP version 6 EIGRP on the router with autonomous system 001 and router ID of 2.2.2.2. So back to remote router, exit, IPv6 Unicast routing, IPv6 router, EIGRP, autonomous system of 65001, and the EIGRP router ID of 2.2.2.2. Now, on the interfaces, interface gig 00, IPv6 EIGRP 6550-65001, and the interface of gig 01 IPv6 EIGRP 65001, and the last interface on serial 000 IPv6 EIGRP 65001. Now I'm done for now with the remote router, so let's do some configuration on the main router, this guy here. Enter. I will configure NAT first on the router. Configure terminal IP NAT inside source list 1 on the interface of serial 000 overload. So now we have the interfaces of gig 01, gig 00, and the serial 000. So the gig 00, this is IP NAT. I keep typing IP NAT inside, and the interface of gig 01 IP NAT also inside, and the interface of serial 00 IP NAT outside. Next, I will configure a default route on the router. Exit, IP route for any network with this subnet mask, and its gateway for the main router will be, or next hop will be on this interface of 209.165.200.230. 209.165.200.230. Enter. Next, I will configure DHCP on the main router just for one LAN, which is LAN 2 here. IP DHCP, first the excluded IP addresses starting from 192.168.2.1 to 192.168.2.9. And because the LAN on the DHCP, the LAN is on the interface of gig 00, so I will name it G0. Now for the network of 192.168.2.0/24 subnet mask, and the default router of 192.168.2.1, and the same DNS server on 209.165.201.29. Now let me see if the PC received the IP address. Click on the DHCP here, and sure enough it did. Now I will configure IP version 6 EIGRP with autonomous system 65001 on the router. So back to the main router, exit, IPv6 Unicast routing, IPv6 router, EIGRP, with autonomous system of 65001, and for the router ID of 111. Exit. Now on the interfaces of gig 00, IPv6 EIGRP 65001, the other interface of gig 01, IPv6 EIGRP 65001, and the interface of serial 000, IPv6 EIGRP 65001. Now, I will move to the outside router here. Enable. Here I will configure a username of admin1 and privilege for this user of 15, the highest, and a password of Cisco. Configure terminal, username, I'll name him admin1, privilege of 15, and password of Cisco. And another user, username, I'll call this user as user, and password also of Cisco for the simplicity of this lab. Next, I will configure SSH on the router. So line VTY, 5 lines from 0 to 4. Transport input is SSH, and to log in with the local using exit. I will configure a domain name, give it the name of company, private, enter, and encrypt the key, generate RSA. I will use 1024 bits, the size of this key, enter. Next, also here on router, the outside router, I'll configure the DHCP. IP DHCP now exclude the excluded address of 192.168.3.1 to 192.168.3.9. Because the LAN here on gig 01, I will use IP DHCP, the name of it G1. And the network of 192.168.3.0/24 subnet mask, and the default router of 192.168.3.1, and the same DNS server 209.165.201.29. Enter. Let me see if this PC received the IP address, that our configuration is correct, and sure enough it is. Now I will configure NAT on the outside router. Exit, IP NAT inside source list 1 on the interface of serial 000, overload, enter. I have the interface of gig 01. This is for inside, and the interface of serial 000, this is to NAT outside. Now I will configure IPv6 EIGRP with autonomous system 65001 on the router. So IPv6 Unicast routing, IPv6 router EIGRP with autonomous system 65001, and the router ID of 3.3.3.3. Now on the interfaces, interface of gig 01, IPv6 EIGRP 65001, and the other interface of serial 000, IPv6 EIGRP 65001. Next, Here I will configure a default route on the router, exit, IP route to any network with this subnet mask, and its gateway will be on this interface of 209.165.200.237. Enter. Now I will move to the ISP2 router here. Enable. Here I will configure EIGRP with autonomous system of 65001. Configure terminal, IPv6 Unicast routing, IPv6 router EIGRP with autonomous system of 65001, and the router ID of 5.5.5.5 for ISP2. Exit. Now for the interfaces of gig 01 IPv6 EIGRP 65001, and the other interface of serial 000, which is connecting or the link with the outside router, IPv6 EIGRP 65001, and the interface of serial 011 with ISP1. IPv6 EIGRP 65001. Now, also on the ISP router, I'll configure DHCP. Exit IP DHCP excluded addresses 209.165.201.1 to 209.165.201.9. Yep, I put 2 dots there. Delete, enter. Now, because the LAN is on gig 01, I will call it G1 for the pool. Enter. Now, the network of 209.165.201.0 with the /27 subnet mask, the 224, the default router of 209.165.201.1, and the DNS server of 209.165.201.29. Now let me see if this PC, the external PC, received its IP address, and sure it did. So now I will configure static routes on ISP2. I will configure the first one. It's the network between remote and ISP here, and the second one between main router and ISP1, and the third one, it will be to the main server on LAN to this network here. So back to ISP2, exit, IP route 209.165.200.224 with /30 subnet mask, and its gateway will be on 209.165 of 200.233. Second route or route to 209.165.200.228 with the subnet mask of 30/30 255.255.255.252, and the next hop or the gateway of 209.165.200.233. Enter. And the third route or route to the main server LAN on 209.165.202.128 with /27 subnet mask 224, and the same next hop for gateway 209.165.200.233. Enter. Next, I will configure ISP1. Enable. I will configure first IPv6 EIGRP Autonomous System 65001 on the router. Configure terminal, IPv6 Unicast routing, IPv6 router EIGRP with autonomous system of 65001, and the router ID of 4.4.4.4. Now, on ISP1, on the three interfaces, interface of serial 011, IPv6 EIGRP 65001, the other interface of on serial 01, IPv6 EIGRP 65001, and on the interface of serial 000 65001. Now, I will configure PPP and Chap on the ISP1 router. On the interface, the two interfaces, the link with remote router and with the main router. Exit. So on the interface of serial 001, encapsulation PPP, PPP authentication Chap, and the other interface of serial 000, encapsulation PPP, PPP authentication Chap. I will configure two usernames. The first one is main with the password of Cisco, and the second one is remote with the password of Cisco. Exit. User name, main, password of Cisco, and the other one of remote and the password of Cisco. On the ISP1 also I will configure BGP. So the command goes like this: router BGP with autonomous system 65001. Now neighbor of 209.165.200.229 with the remote autonomous system of 65020. Enter. And redistribute static. Exit. So from ISP to the main. Exit. Now I will configure static routes on the router, on the ISP1 router. IP, the one for the external network on LAN of the ISP2. The second one is for the network between ISP2 and the outside router. IP route to 209.165.201.0 with /27 subnet mask 224, and the next hop on 209.165.200.234. Enter. And to the network of 209.165.200.236 with /30 subnet mask, and the same next hop 200 209.165.200.234. Enter. Now, as I'm done with the initial configurations, I will work on the main objectives. I will configure PPP encapsulation and Chap authentication for the serial links. Then I will configure Gre tunnel between the remote router and the main router. Then I will configure OSPF on the network. After that, I will configure BGP, and then I will configure standard and extended IP version 4 and IP version 6 access control lists. Now, when you download the files located on the description of this video, run the show run commands on the devices before you start the lab, and do it on each router individually, one at a time, and take your time studying the configuration I've done so far before you start anything. And now on the remote router, I will configure PPP and Chap authentication on the appropriate interface, and I'll also will configure Gre and OSPF and IP version 4 access control list. On the outside router, I will only configure a standard IP version 4 access control list. But on the main router, I will configure PPP and Chap authentication on the appropriate interfaces, then configure Gre Tunnel, OSPF, and both standard and extended IP version 4 and IP version 6 access control list. Now I will start by configuring PPP encapsulation and authentication for the link between main router and ISP1 router, and the link between remote router and the ISP1 router. So on the main router, enable, so configure terminal on the main router on the interface of serial 000, interface serial 000, encapsulation PPP, enter. I'll do the same on the remote router, but also here on the serial 00. Enable, configure terminal on the interface of serial 000, encapsulation PPP, point-to-point protocol, enter. Now we configured already PPP and Chap on the ISP1. Next, I will configure Chap between the links. Now on the main router, PPP authentication Chap, and the same on the main router, PPP authentication Chap. Let's see, give it a second. Now on the main router, here, I will configure a username, exit, username ISP1, the password of Cisco. I'll do the same on the remote router. Exit from here, username of ISP-1 with password of Cisco. Let me see, just give it a second. With backtrace, it takes a little bit to converge. Now I will configure GRE, here we go. And the same will be on the remote router. Here we go. Okay. Now I will configure Gre Tunnel with routing between the main router and the remote router. So I'll configure this Gre tunnel 0, with the network of the tunnel of 172.16.1 172.0/30. So start with the main router. Interface for tunnel 0. The tunnel mode GRE over IP. The source here will be on the interface of serial 000. Tunnel source on serial 000, and the destination packet tracer will allow us only to use the IP address of 209.165.200.225. 209.165.200.225, and the IP address of on the main router for the tunnel of 172.16.1.1/30 subnet mask 255.255.252. Now we'll do the same on the remote router. Interface for the tunnel 0. The mode of this tunnel GRE over IP. The source on the remote router is on the interface of serial 000, source serial 000, and the destination on the IP address of 209.165.200.229. This interface here on the main router. Enter. And now for the IP address of 172.16.1.2 with /30 subnet mask of 255.255.255.252. Enter. Next, I will configure OSPF 1 to route the traffic between the LANs of main router and remote router through GRE. And I will use here the area 0. So on the main router, we want the network of the tunnel and LAN 2 to route the traffic through the GRE tunnel. And we want the LAN 1, LAN 2, and the GRE network on the remote router. So on the main router here, exit, router, OSPF process ID of 1. Now the network of 172.16.1.0 with the inverse subnet mask of 000.3 area 0. This is on the main, and the other network of LAN 2 of 192.168.2.0 with the inverse subnet mask of 000.255 in area 0. Now I'm done with the main configuring OSPF. So now to router 3, exit, router, OSPF, process ID 1. We have 3 networks here. Start with the tunnel network of 172.16.1.0 with the inverse subnet mask of 000.3 in area 0, and the second network of 192.168.0.0 with the inverse subnet mask of 000.255 in area 0, and the second network of 192.168.1.0 in area 0. Next, I will configure the main router with BGP. I will configure BGP between the ISP1 and the 209.165.202.128, which is the main server network, and it is /27 on the main router. I will use the autonomous system of 65020 on the main router. So on the main router here, exit from here, and the command goes like this: router BGP autonomous system of 65020. Now ISP1 should be used as the BGP neighbor. So neighbor of the 209.165.200.230 and the remote autonomous system of 65001. Now I will advertise only LAN 2 on the main router with the IP address of 209.165.201.98/27. So the network of 209.165.202.128, and this is on the mask of /27 255.255.255.224. Let me run this command for IP route, and as you can see, we have OSPF configured. This is on the main router to LAN 1 and to LAN 2, and this will go through the tunnel, as you can see, on tunnel 0, and the BGP also is configured on the main router. Next, I will configure access control list for NAT. I will configure a standard access list numbered 1 on the remote router to allow NAT translation for hosts in the network of 192.168.0.0/23, which I can do these two networks individually, but I'll do both of them in one network. It will be 192.168.0.0/23. So here on the remote router, exit access list 1 to permit the two LANs of 192.168.0.0 with the inverse subnet mask of this. Enter. Next, I will configure a standard access list numbered 1 on the main router to allow NAT translation for hosts in the network of 192.168.2.0/24. So on the main router, configure terminal access list 1, permit 192.168.2.0 with the inverse subnet mask of this. Enter. Next, I will configure also a standard access list numbered 1 on the outside router to allow NAT translation for hosts in the network of 192.168.3.0/24. On the outside router, enable configure terminal access list 1. We want to permit devices on the network of 192.168.3.0 with the inverse subnet mask of this. Next, I will configure a standard access control list to restrict remote administrative access to the outside router. A standard access list, I will name it admin, all caps. We configure it to limit access via VTY, via the SSH, to the outside router. This access control list will only allow hosts from LAN attached to the GIG01 interface here, and the host from the LANs on remote router to access the outside router. All other connections to VTY should fail. Okay, now on the outside router, IP access list, and we want it to be standard and give it the name of admin. Okay, I will configure one access list named admin with 3 access control entries. The first one is to allow any host from the LAN attached to the interface of the outside router to access the router remotely. So we want to permit the network of 192.168.3.0 we want to permit I permit the caps. I accidentally hit the button and it's not showing. 192.168.3.0 with the inverse subnet mask of this, the LAN on attached to the gigabit 01 on the outside router. We want to permit that to access the outside router via VTY. Enter. And now the second one is to use NAT translated public address to allow the hosts from LANs in the remote network to access the outside router remotely. So we are still on the outside router. So we want to permit the host of 209.165.200.225. This interface here on the remote router, these two LANs, to access this router remotely using VTY. Enter. Now the third one is to deny all other remote connections. Simply type deny any. Enter. Now I will apply the access control list to the appropriate interface. So exit, access, now because we don't want to be connected to the outside router using the VTY, the SSH, so line VTY for 5 lines 0 to 4, access class, we called it admin, and inbound or in. Enter. Next, I will configure an extended access control list to restrict access to the main router. I will configure an extended access list named HTTP access that allows remote LANs, this LAN here on the remote, remote LANs, and the outside LANs and the LAN inside main router to access the main server via the web browser. I will configure this access control list with 5 access control list entries. The first one, I will use NAT translated public address to allow the host from the remote router LANs to access the NAT translated public address of the main server via a web browser. So now on the main router, IP access list extended HTTP access, enter. I will permit TCP from the host of 209.165.200.225 to the host of 209.165.202.158 on the port 80, or we can use www. Now I will use NAT translated public address to allow the host from the outside router LANs to access the NAT translated public address of the main server via web browser. Here to permit TCP from the host of 209.165.200.238 to the host of 209.165.202.158 equal 80. Enter. Now I will allow main internal network on the 192.168.2.0/24 to access the main server. So we want to permit IP. We did not specify a specific protocol, IP, any protocols from the network of 192.168.2.0 with the inverse subnet mask of 0.0.0.255 to the host of 209.165.202.158. Next, I will allow ICMP echo replies to main server from any network. So permit ICMP from any network to the host of 209.165.202.158 echo reply. Enter. Next, I will explicitly deny all other traffic from accessing main server. Deny IP any protocol from any to the host of 209.165.202.158 to the main server. Enter. Finally, I will apply the access control list to the main routers on the gig 01 interface. Exit on the interface of gig 01. IP access group HTTP access out. Enter. Next, I will configure IP version 6 access list to restrict access to the main LAN. I will configure an IP version 6 list named HTTP 6 that allows remote LANs, the outside LANs, and the LANs inside main to access main server via the web browser. So on the main, exit here, IPv6 access list, we'll call it HTTP and number 6, enter. I will allow the hosts from the remote router on LAN 1 to access the main server. So the command goes like this: permit TCP of 201 DB8 ABCD colon the network or the LAN 1 64 to the host of 2001 colon DB8 ABCD colon B colon 158 equal 80. Now I will also allow the host from remote LAN 2 to access the main server. So permit TCP of 2001 colon DB8 colon ABCD colon 1 colon the network of 64 to the host of 2001 DB8 ABCD B colon 158 equal to the main server 80. Enter. Next, I will allow the host from the outside LAN to access the main server. So permit Dhcp from 2001, a network of DB8 ABCD colon 3 colon a network 64 to the host of 2001 DB8 ABCD B colon 158 equal 80. Next, I will allow the main internal network on LAN 2. So permit IPv6. We did not specify a protocol also here from 2001 DB8 ABCD colon 2, just one host, on LAN 2 /64 to the host of 2001 to the main server DB8 ABCD colon B colon 158. Here for the LAN 2 on the main server, we did not specify a specific or a protocol, so any protocol can access it with any protocol. Enter. Next, I will allow ICMP echo reply to main server from other networks. So the command goes like this: to permit ICMP from any to the host of 2001 DB8 ABCD B colon 158 echo reply. Finally, I will apply the access control list to the main routers on the interface of gig 01. Exit from here. So now on the interface of gig 01, IPv6 traffic filter HTTP number 6 out. Enter. So that's it for this lab. Sorry, it took a long time here to do the configurations. I covered a lot of protocols and configurations here on this lab. I hope you learned something or two. Now, when you do this lab, just also read where you can ping and when you cannot ping between the networks using IP version 4 and IP version 6. Thank you so much for watching. I will see you soon in my next video. Please, if you like this video, subscribe to my channel, tell your friends about it, and share this video on your Facebook page. Thank you so much. I'll see you soon in my next video.